can't believe that it's November 1st and we can still like be in shorts. I mean, I handed out candy last night sitting on my front porch swing. Yes, I have a porch swing. I'm that guy. And it was kind of cool, creepy. You know, I had jack-o'-lantern, all these creepy spider webs and stuff. And I'm sitting there in shorts and just a light coat, just handing out candy. There was a ton of kids last night. For a Monday night Halloween, it was like, dude, there's a lot of kids. I thought it was cool. So yeah, I'm that guy who sits out front. I enjoy. I mean, Halloween's about kids, and it's cool. So I hope you all found enjoyment out of it. Well, we have the minis, but I'm the guy with here's a fistful. So all of a sudden you're starting to see the same costumes over again. But the guy down at the end of the cul-de-sac, man, he's the full-size candy bar. You see kids like, man, you're like pushing the parents out of the way. Kids getting out of their stroller running, full size. So I'm sorry, I'm not that guy. I would like to be that guy, but my wife, she has rules. She acts like, oh, the obesity epidemic, and I'm like, who cares? Kids are gonna choose to eat chocolate no matter what. But I don't know. All right, so, but that's here and there. Is there any questions about the homework? How'd that go? Yeah. 11A. Let's take a look. We'll go to 11A. Okay. Let me see if I can draw this appropriately. So this is 11A, and it's. I have these that are parallel to each other, right? We do know that. Get that and that. And then this is 43 and Y. This is 75 out here. And X. Okay. So as you look at number 11, things that you have to understand that are totally always okay to do is extend your lines. Even though it does make this shape, it's totally okay to always extend your lines. So you start recognizing that you're working with transversals and things like that. So right now, this angle and this angle are congruent to each other because they are alternate interior angles, being these two lines on top and bottom are parallel, alternate interior angles. So X is equal to 43 degrees, and you could say that they are alternate interior angles if you wanted to. I don't know if they asked you to or not. Nope, they just said find X and Y. And then if I wanted to find this angle here, I have to recognize this forms a linear pair. So that means that this has to be 105 degrees. Is that right? Right. Okay. And then help me out with a calculator. Let's see. 43 and 105 is 148. And what's 180 minus 148? 42. 42? 32. Thank you. So our Y value is 32. Yeah.
How did you find X?
Okay, so this and this are alternate interior angles to each other because the two lines are parallel, and if the two lines are parallel, then we can say that the alternate interior angles are congruent. Cool? Yeah. 11C. 11C. Ooh, okay, it's a big triangle. And we know that this forms a 90. And 25, that's 25 degrees. And that's 20 degrees down here. And that's X here and Y here. Is that right? Is there any more information about that? Okay. All right. So I'm going to use highlighter a little bit on this. See if this works. Okay, so I need to realize that we have this triangle right here. We're doing the smaller triangle, this one right here. Can you see the big yellow triangle that I'm looking at? Yeah. All right, so let's go from there, see what we can do. So the three angles of a triangle have to add up to 180. So if that's 20, this has to be also 70. Is that correct so far? Yeah. And I know that's not what it's asking for yet, but I'm just trying to get through it. If that's 70, then this angle here has to be 110 degrees because of you know, linear pair. And then I know that this is 90 degree because those two have to add up to 180. So then if I go back to my highlighter, go into here, this triangle here, that whole big triangle there, I know that if that's 25 and that 25 plus y plus 90 has to equal 180. So that would be
105, and then that means 75. Y is
75? Is that right? Or is it 65?
No, 65.
65? Okay. So that has to be 65 degrees because the blue triangle, the 25 plus 65 plus 90 has to equal 180. Okay, we're good there. I also know that this angle here has to be 70 degrees because those are vertical angles to each other. Is that right? And then I have to know that 25 plus 70 plus x has to equal 180. So I get 95 minus 180 minus 95 is 85. So that's then 85 degrees, and then that's done. So definitely on these you have to use things that you have to know. You have to solve for other angles that might not be asked for, but that's okay. What else do we got? Yeah. 11B. All right, 11B. Okay, so we have a line like this, and then we have a longer line, right? And those happen to be parallel to each other. That's important. And then we have a triangle down here. Comes up like that, I believe. And then that forms that. And 22y. We have x. And we have y. And we have, is that 22? And we have 118. Okay. So again, this might be one that you might want to extend some of your lines, start realizing that you have transversals and other fun stuff. I don't know if they'll all be necessary, but just in case. Okay. So this angle here and this angle here have to be equal y. They're corresponding angles. Good. So this has to be 118 degrees. Okay, and then if I know that, then I know that this angle and this angle are a linear pair. So the two of those would add up to 180. So 180 minus 118 is 62. Thank you.
You're so smart. Thank you.
And then, I just goofed up. That's 22 down here, right? This is a 22 degree angle. Okay, so then I know that these three angles have to add up to 180. So 62 plus 22 is 84. And 180 minus 84 is 96. So that angle there has to be a 96 degree angle. Oh, cool. These are fun. This is like, Mensa problems. That's a smart people organization you have to apply to be a part of.
Illuminati.
Sure.
Inferno is a good movie.
Illuminati. Yeah, I tell you what. I love any conspiracies. Like, in my opinion, every conspiracy out there is true. Because I'm like that dude. The moon landing never did happen. It's a hoax. But, some people get offended by it. No, we put people on the moon. But, all right. Yeah. 11E, you got it. 11E. Oh, okay. So that's get this triangle here, and we got this one's like a 90, I believe. So we get that, and then we have x and y. Oh, dude. Wait, hang on. I totally goofed this picture up. I'm sorry. All right, 11E. So I know that's a 90. And this takes place, I think. And then this takes place. Does that look a little better? I think. Gosh, I don't know. And that's X and that's Y. Anything else we know? That's 15 to 47, so this is 15 degrees, and that is 47 degrees. Okay. So this triangle right here, all right, I know that the three angles have to add up to be 180 degrees. So I have 15 and 47, that's 62, and 180 minus 62, how big's that angle got to be then?
118.
8, what, 118? 118 degrees. And I know that these two angles have to add up to 180, or I could have just summed those up. So this is a 62 degree angle, and then 62 plus 90 is 152. 180 minus 152 is 38?
28.
28, okay. There we go. Cool. Anything else from the homework? We good? Yeah.
Can you just go over like the right side of 10?
Okay, I'll just run through the whole thing on 10. Okay, cool. All right, number 10. We got this, and then we got here. Goes up, over, down, over. Okay. That's a 90, and that's a 90, right? And I got 1, 2, 3, 4. Okay. 40 and 20 here. Okay. 5 and 6. Okay. First thing I would work on, let's see, I'm going to do this triangle here first. And so I know that I got 90 and 40 is 130, so this has to be 50 degrees. If that's 50, that means that's what? Vertical angles, yes. Vertical angles are there. And I know that these two angles have to add up to 180, so that's 130. And then this is also 130 because of vertical angles. Is that okay?
Nice.
Okay. And then I know that 50 and 90 is 140. So this has to be 40 degrees. Oh, wait a minute. Does that really gonna work that way? Hang on. This big triangle here, that big old triangle there. Let's see. So I have 20 plus 90. That's 110. So this whole angle here, if that's 110, would have to be 70. And we are accounting for 40 degrees right there. So that means that has to be 30 degrees right there. And I guess there's other ways we could have done that. We could have did 130 or 20 plus 130 is 150. And then the smaller triangle here has to be 180, so that would be 30 as well. So that's how you can do it. Is that right? No, I kind of think I have a lot of nice colors up there. All right. Is that okay? Any other questions from the homework?
Oh yeah,
9A. 9A. Ooh. 9A. We have that. X and 45. And is that 2x minus 2? Is that right? Right here? Is that right? Okay. Anything else we know about that? Okay. All right. So I'm going to talk about this blue triangle right here for a second. I know that this angle right here is 180 minus 2x minus 2, which is the same as 178 minus 2x. How did I get that? It's a linear pair. Does that make sense? So then I can add up the three angles in the blue triangle. So I have 178 minus 2x plus x plus 45 equals 180. Is that all right so far? So I get what is 178 added to 45? Help me out. 13. Is it 223?
Yeah.
223. If I add those together, I get minus x equals 180. If I subtract 223, this is going to be negative 43. And negative, that means that's positive, so x equals 43 degrees. So that's going to tell me that this here is 43 degrees. If that's 43, then I can figure out actually what that is. I can do it a couple of ways. I can plug 43 in for x. So I could do it right here. I go 178 minus 86 because 2 times 43. And what does that come out to? What's 178 minus 86? How much? 92? 92? Okay, so that's 92 degrees. So this angle here is 92 degrees. And I know that this angle plus this angle have to give me 180, so I get 2x minus 2 plus 92 equals 180. So I get 2x plus 90 equals 180. 2x is equal to 90. So x is equal to 45. So 2x, that's 90. This is an 88 degree angle then here. What's 47? X is 47?
Yeah.
Oh shoot. 180 it's 47? Man, why didn't you guys stop me? We tried, but you just kept going. So if that's the case, uh-huh.
Well, wait, because you get yeah, you already get that x is 47.
That's 47 right there.
Because you plugged it back in.
Yeah, then I have to go figure out this third angle. What's 47, 45? Someone with a calculator?
92.
How much?
92.
92 minus 180 minus 92? 88. That's 88 degrees there. Then those two have to add up. I got the hiccups to 180. Which 92? Sweet. All right. There we go. Woo! Hey. Any other errors? I don't know. Yo!
On this one, could you do x plus 45 equals 2x minus 2?
Oh, yeah. Oh, I wish I would have seen that way. So you could have went x plus 45 is equal to 2x minus 2. That would have been so much quicker. I'm glad I got you guys here. I would have saved so much time. You're welcome. You guys are awesome. Good call. That's the old exterior angle theorem of a triangle. I like it. We talked about that yesterday. All right. How are we at? We good? Solid? All right. Make sure your homework is stapled and bring. It's fine. It was fun.
Good chair.
All right. Let's. All right. Section 4.2. We are applying congruency in polygons. The extended understanding for correctly naming congruent figures and using congruency to find missing measures. Okay. So we've covered a lot. We've covered. We have the whole vertical angles, corresponding angles, alternate interior angles, same side interior angles, or consecutive interior angles, alternate exterior angles. We have a lot of rules that we know. We know that triangles, the sum of the three interior angles have to add up to 180. We know the linear pair is also 180. There's kind of a lot of little tidbits that we have there, and let's see if we can start getting them in the right order. All right. What is the definition of congruence? I don't know. I bet you there's something hiding here.
You have to write.
Dude, I have to make something up?
Oh my goodness.
All right. What is the definition of congruence? I'd say,
Sweet.
I mean, that's the simplest thing I can think of. Congruent and equal, they go hand in hand. Okay? So if two triangles are congruent, what must be true?
They are equal.
They are equal. That means everything about them are equal. So if I knew I had this triangle ABC, you still with me in this story? And I knew I had X, Y, and Z. We don't have a fun song with that. Angle A and angle X go with each other. B and Y are the same. C and Z are the same. Segment AC and XZ. So we could go through this whole thing saying, this is congruent to this. This is congruent to this. These are congruent, meaning they're the exact same size. And then I could go through saying, okay, this segment here and this segment here are congruent. And this segment here and this segment here are congruent. And this segment here and this segment here are congruent. So they're the same. So they're interchangeable. Does that make sense? Huh. So if two triangles are congruent, what must be true? Everything about them must be congruent. Okay? The appropriate angle goes with the appropriate angle, and it's the same. All right, corresponding parts. Ooh, there's something here. The triangle must be named Fred, Bill, Reuben. Okay. We named them. Okay, so that the corresponding parts are named in the same words. Oh. So if triangle, bless you. If triangle DBA is congruent to triangle NOE, that means angle N and D go together. Angle B and O go together. Angle A and E go together. Segment DB and NO go together. Segment BA and OE go together. And segment DA and NE go together. So if you name two triangles that are congruent to each other, the order of the letters is important. I'm not quite sure what that third triangle has to do with, but maybe we'll investigate and figure it out later. How are we feeling? Okay so far on 4.2. So the triangles must be named, so the corresponding parts. So we use, usually, I mean, we can say triangle A, which if we refer to one single triangle, but if we said if triangle A is congruent to triangle B, that doesn't tell you anything about the order of the letters in the sequencing. So the important part about this is knowing that D, N go to each other, B, O go to each other, and N or AE go together. That's the important part to know. And then you have the particular segments that are the combination of the three letters. May I move on? Yes, you may. Thank you. All right. Given that two triangles are congruent, mark the diagram to show the congruent parts. Well, I would say that this angle and this angle go with each other. And a lot of people jump right on that going, do the vertical angles. No. And then I would say that this angle goes with this angle. That's what the double ticks mean. And then the triple ticks would go there. And then we could go single tick to single tick, double tick to double tick, triple tick, triple tick. They all go with each other. Okay, if we wanted to list them, we could say that segment AN is congruent to segment TM. We could say that segment AU is congruent to segment TU. We could say that segment NU is congruent to segment MU. I could say that angle NAU is congruent to angle MTU. And then I could say that angle AUN is congruent to angle TUM. And then I could say that angle UNA is congruent to UNA UMT. And you know that when you name an angle, the middle letter refers to where the vertex is of that angle. Oh, look, NAU, that's the university in Flagstaff, Arizona. You know what this stands for? Northern Arizona University, but you know what it really stands for? Not a university. If you live in Arizona, especially if you go to Arizona State. That's what it means. Some people are like, wait, that offends me. Well, good, it should. Sweet. Does that all make sense? Now you guys are trying to make other things. You know what I'd be really good about now? In and out, double double.
Oh yeah.
Yeah, baby.
With the animal fries. Animal fries.
Giddy up.
And the chocolate milkshake.
Yeah, baby.
No, the Neapolitan milkshake.
Neapolitan, go with all three flavors.
The secret
Secret menu. Now, if next time y'all go to In-N-Out, go for the 4x4 or go by the 8x8. I mean, you can get whatever. Depends how much you want to clog up your heart, but it's still worth it. All right. Given triangle dog is congruent to triangle cat. List all the corresponding parts. Well, they have all the tick marks. So give 3 correct congruent statements. Well, we can say that AC is congruent to Wait, where did cat go? Dude, that's not triangle cat. Big jerks. They try to confuse me. WX? All right. Okay, I think we're trying to do this. These are congruent statements here, because that's not even dog, cat. I'm sorry. And then, let's see, then I could say AC, WX. I could say BC is congruent to WY. Those are just the segments. And then I could say that angle ABC is congruent to angle ABC XYZ. So we listed 3 congruent statements about it. Yes, I could have listed all 3 of the segments. I could have listed all 3 of the angles or any combination. With this, I could say that segment DO goes with segment CA. I could say that angle DOG is congruent to angle CAT. Anywhere we want to mix it up, or we could say that segment DG is congruent to segment CT. So that's all stuff that we could say about it. Again, we could have listed all the angles are congruent to each other, all the segments are congruent to each other. Just have the appropriate order. Cool. All right. Can I move on? I don't know. Can you do?
We're at the bottom.
Bottom? All right. Ooh, given ABCD is congruent to FGHK. So that means that angle A goes with angle F, angle B goes with G, angle C goes with H, D goes with K. Sweet, we can do a whole bunch of good stuff here. So, let's see. Angle A goes with angle F. So if that's true, that has to be 80 degrees. Still with me? Okay, and we're just trying to find X and Y. That means that angle B goes with G. B goes with G. So if B is 136, then I know that 10y plus 16 equals 136. So 10y equals 120. Y equals 12. Did I do that right?
Yep.
Cool. Let's see. AB and FG. AB and FG. So this is equal to this. So I got 3x minus 6 is equal to 9. So 3x is equal to 15. X is equal to 5. Oh. You guys see all that? See what I just did? I guess I labeled A and F. I didn't have to put the 80. I just kind of got excited because I knew things were equal.
Mr. Stewart,
Yeah.
I was telling a scary story yesterday. Could you do it now?
Yes. You have an F class. You'll be
Nice.
No way. What?
Not telling a scary story. Okay. Let's see. Can I move on? Sawyer, who are you playing with?
Oh my goodness.
Okay.
Tony, what
Sorry.
are you doing?
He's playing around.
I chased.
All right, let's move on. Let's see. Angle 1 and angle 2. Uh-oh. What are angle 1 and angle 2? Well, that's, how much is that? 30? So if that's 30, and that's 30, sweet, okay. What are the measure of angle 3 and the measure of angle 4? Well, that's 150, and that's what, then 30? And then that's then 30. So notice this. Is this triangle congruent to this triangle? Is everything equal?
No.
Between these, are these congruent? No. Even though all the angles match up, the segments don't. These appear to be. They look about the same size, but these aren't. So angles, having the three angles does not mean that you are able to say that the two triangles are congruent. Yeah.
Would you be able to make it so the angles of
So the point on this is, if I have an angle and an angle and an angle congruent to an angle and an angle and an angle of another triangle, just because those angles are congruent, it doesn't mean the two triangles can be congruent. It's going to be a word that they're going to start referring to as similar. Similar is this sign in math. So it means what a similar shape would be like if you were to take a picture on your phone of your friend and you look at the picture of your friend, as long as you didn't have one of those weird apps that puts like a crown on him and droops her face and makes her tongue look funny, all those weird things that you have. If you look at the picture of your friend, you know it's your friend because all of the angles are maintained in the sizes and shapes that they should be. But obviously, the picture on your phone is a much smaller version of what your friend looks like in real person. But you can still identify as your friend. So that's what similar means. You're maintaining the angle size, but you're not maintaining the integrity or anything else. What about measure of angle 5 and angle 6? Well, let's see, angle 5. So 25 and 35 are 60. So this would be 120. And then this would also be 120 degrees. And again, they are not the triangles themselves are not congruent to each other. It just happens to be the angles. So not everything about these triangles are congruent. It's just the angles happen to be the same size. All right. Ooh, might be something here. Nothing there?
There's a thing at the bottom.
Oh, it's here. Okay, your workbook will refer to this as the no choice theorem. If, I kind of want to say like there's something here. Oh, it's 2 words. If the interior angles of one triangle are congruent to the interior angles of another triangle, then the triangles, then the what? And the interior angles of, oh wait, then the what?
The interior angles of the angles. Wait, what?
The interior angles of the angles are congruent.
The interior measurements of angles?
The measure of measurements, okay. So you're a smart kid. I love you, man.
Thank you.
It's the interior measures of the angles are congruent. Okay. Sweet. All right. So this workbook is the no choice theorem. Okay. Almost done. Ooh. So if this is 40, then this has to be 40. Agree? If this is 35, then this has to be 35 because they're single ticks and double ticks. Find the measure of W X or Y X W. Y X
W.
This right here. Here. That.
Oh, you got this. Okay, it's 40 plus 35, and then you find the remaining.
Yeah, baby.
180.
That's it because you have the big old triangle, right?
You got
Oh, yeah.
this.
That's
You got
105, right?
You got
105
this.
total angle.
Nice, nice.
Woo! No
Nice.
applause, just throw money. No applause, just throw money. Uh-oh, someone's throwing something.
Eugene.
Remember, markings indicate congruence even if the figures do not look like it. Okay? Yeah.
Okay, so what you just did is you added 40 plus 35. And
Yeah.
then you,
This is what we did right here. Highlighter. We'd use this triangle here. And being we knew those 2 angles, then it had to give us that whole angle. We ignored this 35.
oh, gotcha.
Ready? Go. Here in 4.4, reflexive, symmetric, and transitive properties work on congruent triangles. Okay. Oh, there we go. Reflexive, triangle ABC is congruent to triangle ABC. Duh. Symmetric, if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. Okay, good. And then transitive, if triangle ABC is congruent to triangle RST and triangle RST is congruent to triangle XYZ, then triangle ABC is congruent to triangle. So remember, you have to have 3 things for transitive property to work. Do this one. It's too dry here. There it goes. Just fun. Almost there. Are we done? We're done. What is that? Oh, homework 4.2. 4.2. And then quiz Friday. Oh yeah. Everyone feel good? Everyone happy?